And you know that golden telescope we humans built, it's taking some mind-blowing pictures of space right now. Well, it turns out it's so powerful it might have just shattered our understanding of the universe. Betelgeuse, the massive red supergiant star located in the Orion constellation, has long captivated astronomers and stargazers alike. In recent years, this cosmic giant has been the subject of intense scrutiny, particularly after an unprecedented dimming event in late 2019 and early 2020. However, in a stunning turn of events, the James Webb Space Telescope JWST has recently detected an extraordinary 1000% increase in Betelgeuse's brightness, sending waves of excitement and intrigue throughout the scientific community. Before we start, please don't forget to like and subscribe to our channel for more updates. This sudden surge in brightness has left astronomers both puzzled and eager to understand the underlying causes. Betelgeuse, one of the largest stars visible to the naked eye, is nearing the end of its life cycle, a phase that makes it prone to dramatic changes in brightness and behavior. The unexpected brightening is one of the most significant and unusual phenomena observed in the star's recent history, defying current models and theories that have long governed our understanding of stellar evolution. Betelgeuse's size and proximity to Earth make it one of the most studied stars in the night sky. It is a red supergiant, a type of star that is many times more massive than our Sun and considerably older. Betelgeuse is nearing the final stages of its life, and when it eventually exhausts its fuel, it is expected to explode in a supernova. This eventual explosion is a well-established outcome for a star of its kind, but the precise timing remains a mystery. The recent increase in brightness has only heightened speculation about what might be happening deep within the star. The sudden brightening detected by the JWST is surprising for several reasons. Betelgeuse's brightness has fluctuated in the past, but these changes were gradual and followed predictable patterns tied to the star's pulsations. Red supergiants like Betelgeuse are known to undergo cycles of expansion and contraction, which naturally causes their brightness to vary over time. However, a 1000% increase in brightness is far beyond the typical fluctuations expected from these pulsations. The scale of this event suggests that something far more dramatic is occurring within the star's core, or in its outer layers. One possible explanation for this event is that Betelgeuse may be entering a new, more unstable phase of its life. As stars of this size age, their outer layers can become increasingly unstable, leading to sudden and massive outbursts of energy. These outbursts, sometimes referred to as shell ejections, occur when the star expels significant portions of its outer material into space. If Betelgeuse has experienced a shell ejection of this magnitude, it could account for the dramatic increase in brightness observed by the JWST. Another potential cause of the sudden brightening could be related to changes in Betelgeuse's core. As red supergiants approach the end of their life, the fusion processes at their core begin to shift. Betelgeuse is believed to be fusing heavier elements such as oxygen and silicon in preparation for its eventual supernova. Changes in these fusion processes can trigger violent and unpredictable behavior in the star's outer layers. The recent brightening could be a sign that Betelgeuse is entering the final stages of its life, and while this doesn't necessarily mean a supernova is imminent, it does suggest that significant changes are underway. Despite the excitement surrounding this event, it is important to note that Betelgeuse's behavior has been enigmatic before. The star's famous dimming event in 2019 caused widespread speculation that it might be on the verge of a supernova. However, subsequent observations revealed that the dimming was caused by a large cloud of dust injected by the star, which temporarily obscured its light from Earth. This recent brightening could be similarly misleading, possibly caused by another dust-related phenomenon or some other external factor. Yet, the sheer magnitude of the brightness increase detected by the JWST suggests that this is more than just a passing event. If Betelgeuse is indeed on the cusp of a major change, it could offer scientists an unprecedented opportunity to study a red supergiant in the throes of its final stages. While we have observed supernovae in distant galaxies, Betelgeuse is close enough that any such event would be visible in extraordinary detail. This proximity means that if Betelgeuse were to explode, we would be able to observe the process in real time, capturing data that could significantly enhance our understanding of stellar evolution and supernova mechanics. The implications of Betelgeuse's sudden brightening extend beyond the star itself. A supernova within our galaxy would have far-reaching effects on the surrounding region of space. Fortunately, at a distance of approximately 640 light-years from Earth, Betelgeuse is far enough away that any potential supernova would not pose a direct threat to our planet. However, the explosion would still be an awe-inspiring and potentially transformative event. For weeks or even months, Betelgeuse could become visible in the daytime sky, rivaling the brightness of the moon. The event would provide astronomers with a wealth of data on the aftermath of a supernova, including the formation of neutron stars or even black holes. In the immediate aftermath of this brightness surge, astronomers are scrambling to gather as much data as possible. Observatories around the world, both ground-based and space-based, are turning their attention to Betelgeuse, hoping to capture every nuance of this unfolding drama. The JWST, with its unparalleled ability to observe in infrared wavelengths, is particularly well suited to study Betelgeuse's outer layers and the material it may be ejecting into space. The telescope's observations could reveal whether this increase in brightness is due to a significant change in the star structure or if it is the result of an external factor, such as dust or gas clouds interacting with Betelgeuse's light. This sudden brightening has also sparked renewed interest in studying other red supergiants. While Betelgeuse is one of the closest and most prominent examples, there are many other stars in the Milky Way that are in a similar stage of their life cycle. If Betelgeuse's behavior is indicative of a previously unknown phase of red supergiant evolution, it could lead to a broader re-evaluation of our understanding of how these stars behave as they approach the end of their lives. This, in turn, could improve our ability to predict supernova events, potentially offering more precise timelines for when other nearby stars might undergo similar transformations. The increase in Betelgeuse's brightness also underscores the importance of the JWST and other advanced observatories in the field of astronomy. The JWST's ability to observe the universe in unprecedented detail is providing scientists with new insights into phenomena that were previously difficult or impossible to study. In the case of Betelgeuse, the telescope's observations are offering a front-row seat to one of the most dramatic events in the life of a star, a process that could unfold over years or even decades. These observations are not only deepening our understanding of Betelgeuse, but are also opening new windows into the broader processes that govern the life and death of stars. The mystery surrounding Betelgeuse's sudden increase in brightness is a reminder of the dynamic and often unpredictable nature of the universe. While scientists have made tremendous strides in understanding the life cycles of stars, there is still much that remains unknown. Events like this serve as a powerful reminder that our models and theories, while sophisticated, are still evolving. Each new observation offers the potential to revise or expand our understanding, and the sudden brightening of Betelgeuse is a perfect example of how unexpected phenomena can challenge long-held assumptions. As the investigation into Betelgeuse's sudden and unprecedented 1000% increase in brightness unfolds, scientists are diving into a variety of hypotheses to explain the anomaly. The red supergiant's erratic behavior has rekindled curiosity about stellar processes that remain shrouded in mystery, particularly in the late stages of a star's evolution. Although Betelgeuse is known for its unpredictable fluctuations in brightness due to its pulsating nature, this recent surge is far outside the typical range of variation observed in the star's life cycle. Now, with the James Webb Space Telescope delivering high-resolution data, the astronomy community is racing to understand what might be triggering such an extreme event in this aging behemoth of the cosmos. The JWST's role in this investigation cannot be overstated. As the most advanced space observatory currently in operation, the JWST offers unprecedented access to Betelgeuse's outer layers, which can provide crucial insights into the forces at work inside the star. By capturing infrared wavelengths, the JWST can peer through any dust clouds or atmospheric particles that might have obscured earlier observations, allowing astronomers to study the star's surface and atmosphere with unparalleled precision. This capability is essential to unraveling the cause of Betelgeuse's current state of heightened luminosity, and every new dataset provides fresh leads in the ongoing investigation. One of the most exciting prospects that scientists are exploring is the possibility that Betelgeuse's dramatic increase in brightness could be linked to an internal phenomenon that has, until now, eluded observation. Red supergiants like Betelgeuse are known to fuse progressively heavier elements as they approach the end of their lives, working their way from hydrogen to helium, and eventually to elements like oxygen, silicon, and iron. This fusion process results in extreme pressure fluctuations inside the star, which can manifest as surface instability, violent mass ejections, or even catastrophic events like supernovae. The sudden brightness spike detected by the JWST could be an indication that Betelgeuse has entered a volatile phase of its evolution, wherein its core dynamics are driving unpredictable changes at the star's surface. As the red supergiant nears the end of its stellar life, one of the most important processes occurring within Betelgeuse is the fusion of increasingly heavier elements. Scientists have long hypothesized that as a star of this size fuses elements like oxygen and silicon, it creates a complex and delicate equilibrium between gravitational forces pulling inward and radiation pressure pushing outward. When this equilibrium is disrupted, it can lead to a phenomenon known as core collapse, where the star's core suddenly collapses under its own weight, followed by an immense release of energy.